Good morning, students. I'm Mrs.Sweetly, Assistant Professor of Civil Engineering Department, working in Emmanuel J College of Engineering. Today, we are going to study about the statics of rigid bodies. I'm going to explain one problem from force coupled system which comes under your statics of rigid bodies. The question is, a system of parallel forces are acting on a rigid bar as shown in figure. Reduce the system to first a single force, second a single force and a couple at A, third a single force and a couple at B. Okay, the diagram is given. It indicates 4 point loads are acting. Among that, 2 point loads are acting downward and 2 point loads are acting upward. At C and B point, the point loads are acting downward, and at A point and D point, the point loads are acting upward. The magnitude of the force is given. At A point, the magnitude of the force is 30 Newton, and at C point, the magnitude of force is 150 Newton, and at D point, the magnitude of force is 70 Newton, and at B point, the magnitude of force is 10 Newton. In the question, they asked to find out, reduce the system to a single force, which means we are going to calculate the resultant force. Okay, which means we are going to reduce the given 4 forces to a single force. That single force is the resultant force. Resultant force gives the summation of all the forces. Here we have 4 forces, therefore the summation of 4 forces gives the single force, that is the resultant force. Then they are asking to find a single force and a couple at A, which means we have to find the force couple system at A. Then third, they asked to find out a single force and a couple at B, which means force couple system at B. I hope the question is clear. We want to calculate the resultant force, then force couple system at A and force couple system at B. First, we are going to reduce the given system of forces into a single force system. Here, 4 forces are given. 2 forces are acting downward and 2 forces are acting upward. 30 Newton is acting upward, therefore the sign is positive. Okay, therefore 30. Then 150 Newton load is acting downward, therefore the sign is negative, minus 150. Then 70 Newton load is acting upward, therefore the sign is positive, and 10 Newton load is acting downward, therefore the sign is negative. For upward the sign is positive, and for downward the sign is negative. Okay, then we have to add the forces. 30 minus 150 plus 70 minus 10, you get the value as minus 60 Newton, which indicates the resultant force is acting downward because the sign is negative, minus 60 Newton. The magnitude of the force is 60 and the direction is downward. Next, we are going to locate the resultant force. We find the magnitude of resultant force as 60 Newton, but we didn't know where the resultant force is located. Therefore, we have to find the location of resultant force. How you find the location of resultant force? We have to use the Varignon's theorem to find the location of resultant force. For that, we need the moment. Okay, Varignon's theorem states that sum of moment is equal to the sum of moment about the resultant force. Okay, therefore we have to find the sum of moment first. We are calculating the moment about A is equal to the resultant force about A. Okay, resultant moment about A. First, algebraic sum of moment of forces about A. How we calculate the moment about A? For point load, you have to take the load into distance. If the load is vertical, then you have to consider the horizontal distance up to A point. Okay, based on the rotation, we have to give the sign. If the rotation is clockwise, then the sign is positive, and if the rotation is anti-clockwise, then the sign is negative. Okay, here see this diagram. we are going to calculate the moment about A point from B. Okay, at B point the 10 Newton load is acting downward, therefore the rotation is clockwise, therefore the sign is positive, plus 10 into distance from B to A is 3.5 meter. Okay, 10 into 3.5. Then 17 Newton load is acting upward, which means the rotation is anti-clockwise, therefore minus 70 into 2. Then 150 Newton load is acting downward, the rotation is clockwise, therefore 150 into distance from C to A is 1 meter. Then at A point the load is acting upward, but we have to include the distance also. For point load into distance, the distance here we have no distance because the 30 Newton load is present at A point itself. It doesn't move somewhere from A. Therefore, the value is 0. The distance value is 0. Therefore, 30 into 0. Okay, moment about A is equal to 10 into 3.5 minus 70 into 2 plus 150 into 1, then plus 30 into 0. The value is 45 kilonewton meter. Here we get the positive value, therefore the rotation is clockwise. Okay, the rotation is clockwise. Next, using Marignon's theorem, location x is equal to summation of moment about A divided by R. We already calculated the resultant force. The value is 60. Therefore, 45 divided by 60 is equal to 0.75 meter. Then in the diagram we have going to locate the resultant force and the distance. Okay, AB is a given beam. We are locating the resultant force 60 Newton at a point M at a distance 0.75 meter from A. Then in the question they asked to find a single force and a couple at A, which means the force couple system at A. Therefore, first we have to take the beam carrying a resultant force at a distance of 0.75 meter from A. In the question they asked to find the force couple system at A. Therefore, at A point we have to consider a resultant force 60 kilonewton acting in both upward and downward direction. Okay, at A point, see carefully, we are considering 60 Newton load acting upward and downward. At a distance 0.75 meter, we already have a resultant force 60 Newton. Then we are going to convert it as a couple moment. How we calculate the couple moment? Force into distance, we get the couple moment. Therefore, force value 60 into distance 0.75 is equal to 40 Newton meter. We get the couple moment. Okay, 60 Newton load is acting at a point A and the couple force of 45 Newton meter is acting at A. Thus, we calculate the force couple system at A. Similarly, we are going to calculate the force couple system at B because they asked to find the force couple system at B also. How we calculate the force couple system at B? From the same diagram we are going to calculate, but the distance becomes different because for force couple system at A we are taking the distance from M to A. For a force couple system at B we have to include the distance from M to B. How we calculate the distance MB? We already know the total length of a beam AB as 3.5 meter. Therefore, you have to subtract the 0.75 meter from 3.5 meter. You get the distance MB as 2.75 meter. Okay. Then here we are going to calculate the force couple system at point B. Therefore, you have to consider a resultant moment 60 Newton in both upward and downward direction at B point. Therefore, second diagram, B diagram shows 60 Newton. Resultant force is acting upward and downward direction at B point. Then we are going to calculate the couple moment at B point. How we calculate the couple moment? Force into distance. Therefore, 60 into 2.75 meter gives 165 Newton meter, which is a couple moment at B point. Okay, I hope or if you understand how to calculate the resultant force and how to locate the resultant force and how to convert it as a force couple system at respective point. Thank you, dear children.